click record. Sorry about the slow start. Yeah, you do need to purchase Infinity to do the homework. It's $29. If it takes you a little while to get it, that'll be okay. Like, you know what I mean? Like, if you have like a week or so, because it's not going to be due for a little bit. But yeah, you should work on getting that done as quickly as you can. Like, don't take forever to do it. Okay. Okay, so let's learn some stuff. So last class we left off, we were talking about the different types of variables, so we're going to pick up from there. Buy colored pens for notes, that's a good idea. I like that because I'm on the computer, I can just like change the color as needed. Like I can do any color I want now. Like I can do this cool like teal color. I can choose like magenta, or no, that's like more of a purple. Let's see, do they have a magenta? You can get these like weird greens, all sorts of cool stuff. I love it. It's like really nice to be able to do all this on the computer. Oh, okay, that was funny. I was like, I was thinking that. I was like, well, not that we all needed to know it, but you know, let's celebrate Beatrice's, you know, plans to get markers. So why not? Okay, so let's go forward. Okay, so today we're going to talk about relationships between variables. And we're going to actually end up talking about this a lot this semester, because the relationships that are possible between variables, they occur in different, what's the word here? Combinations. Okay, so the types of relationships that can exist depend upon whether, say, you have one numerical variable and another numerical variable. Or let's say you have one numerical variable and one categorical variable. Or let's say that you have two categorical variables. Yeah, let's start with a refresh. When I talk about a numerical variable, what do I mean? Like, what makes something a numerical variable? So what makes you a numerical variable? Yeah. Yeah, okay, so there are numbers, but that's not just the whole of it. What else? Yes, so the values are numbers and they mean something. They mean in particular that it counts, the numbers themselves count or measure. So there can be numbers, but those numbers may not count or measure. Those would not be numerical variables. Okay, so what about categorical variables? Like, what does a categorical variable do? Exactly. So the values place the subject into a category. Okay, so now that we can remember what these different types of variables are, now we can start talking about the relationships between them. So as an example, I want to talk about what happens if you have two numerical variables. You know, one numerical variable and some other numerical variable. How do we look at the relationship between those variables, statistically speaking? So what does it mean to look at the relationships between variables? Okay, so for this example, I'm trying to scroll down, but it doesn't want to let me. There we go. Let's say that my subjects are going to be countries. Okay, so we're going to look at different countries. And the variables that we're going to record are GDP. GDP is a measure of national production in dollars. So that's something that's measured. It's going to be basically like, if you look at all the if you look at all the goods and services that a country makes, and you add them up at the end of the year, how much is that? That's what GDP is. And then let's look at the another number will be the number of children born per woman. Number of children born. Oh my god, do you guys hear my dog? He wants to go outside, but it's raining. I don't know what to do for him. Can someone let him out? The person in the kitchen? Thank you so much. Oh, good, they just picked him up. Okay, so my other variable will be the number of children born per woman. Obviously, this is counting the number of babies that a woman has. So it counts. So one of them counts, one of them measures. And do you guys remember, if you're dealing with a numerical variable that measures, what sort of numerical variable is that? It's always good to review what we did last time. Well, they will have decimals, but there's a particular name for those sorts of variables. Continuous. Yeah, it's continuous. So this is a continuous numerical variable. Now, because number of babies born counts, that is a discrete numerical variable. So remember, discrete is something that counts, continuous is something that measures, or in other words, we'll have decimals, because you can't have decimals if you count something. Right? There's either one or there's two babies. There's no 1.67 babies. That makes like no sense. You either have a baby or you don't. Okay, so the way we would look at the relationship between these is we would need to graph it. So there's something called a scatter plot. Maybe you've seen this before. If you've taken any math class, you've probably seen it with like an X and a Y axis. So the idea is that one of our variables will be on the X or horizontal axis. Let's make that the GDP. And then the other variable will be on the Y axis. We'll have that be the number of births. Okay, so if you start here, this, like, let's do this in green. This would be like 0 GDP, $0. That means like a country literally made no goods and services. Let's have this be $1 billion. Let's have this be $2 billion, and so on. ... So as you go to the right, how would you describe the countries? They're becoming more what? So as that number gets bigger, how would you describe the countries? Richer or more wealthy country, however you want to say it. Richer. More wealthy. I can't write today. Wealthy. There we go. Okay. So now the dots that will show up on the graph, those will be the individual countries. So my question to you is, as countries become wealthier, do you think women tend to have more or fewer children? So as countries become wealthier, do countries tend to have more or fewer children? What do we think? So, someone give me an example of a very poor country. It's a country that's like known for being very poor. Okay, Africa's not a country, but I like your thinking. Give me a country in Africa. Tanzania? Okay, well, yeah. Let's do Tanzania and Nigeria. So can someone look up births per woman in Nigeria? Let's just see how many babies average woman in Nigeria has. So someone Google it. This is why the internet is amazing. You just go and look. Okay, cool, thank you. Okay, someone think of a very wealthy country. Where's a country that's known? Oh, what? Okay, that's a city. Okay, Europe. Europe is a continent, Paris is a city. We will go with France. Okay, someone look up average number of children born per French woman. Interesting. Wealthier countries, from the two countries we're looking at, wealthier countries seem to have fewer children. And if you were to go and plot this, like if you were to like put dots, like here's a country, here's a country, here's a country, here's a country, and you were to like look at all of the different countries, you would notice that there's a relationship between how wealthy they are and how many children they tend to have. And in fact, the wealthier a country is, the fewer children women tend to have. Okay, you would see that it looks something like this. Okay, so I want to talk about how you would describe this relationship. So do you see how as the country's getting wealthier, the number of babies born per woman is going down? So you could like draw a little line that goes through them, like this. Do you see how they seem to be following the line? Right, they're sloping downwards with the line. Do you remember the learning about slope in algebra class? Slopes can be positive or negative depending on whether the line goes up or whether the line goes down. Okay, so if the dots seem to follow a downward trend like that, we would say that there is a negative association between the variables. So let me write that down right here. So we would say that two numerical variables have a negative association if, when the x variable increases, the y variable tends to decrease. In other words, it slopes down. Okay, so we would call this a negative association. So the key term here is negative association, which I will highlight in magenta. Okay. So that's a negative association. If there's a negative association, what other sort of association do you expect to hear about? And there's also no association. So let's just type that down. Okay, it doesn't want to let me. Okay, so two numerical variables have a positive association if when the x variable increases, the y variable tends to increase as well. That will slope up. So in that case, yeah? Yeah, sure, I'll pause. Oh my god, we got people with cameras on today. Thank you so much. I'm not speaking to like a bunch of little, what's the word? Gray boxes, alone by myself with my dog and my children. In a cruel, heartless world where no one turns on their video. Yeah, what's up? I'm just messing around. Yeah? They'll be there. They're going to be there. I'm not removing them. I'm also posting the links. I'm also saving them on YouTube, and I'm posting them on the Discord. I did that last time, right? Yeah. So you'll have the links, and you can find them by day on there. No problem. What's up, Kenneth? So I'm going to leave this here for a moment. Yeah, there's a Discord. Would you like the Discord link? Yes, I also got my hair cut. Okay, I'll drop the Discord link into the chat. There you go. It's for all my classes, so if you post anything in there, you have to go to the Math 159 channel. Otherwise, no one's gonna know what you're talking about. Oh, and then, oh wow, apparently your little Cash App, that's hilarious. Please change your name to your real name. As much as I find your Discord names hilarious and sometimes not well chosen, please put it to your real name. That way I'm not wondering, like, who is little Cash App, you know, asking me about statistics or calculus or something like that. It's been super hilarious to see like everyone's names in my different classes. I will say that. My children are in there too. They like look to see what everyone posts and looks at. It was really hilarious. My daughter was like, "Oh my God, Dad, I was looking at this and I saw whatever." It was pretty funny. Okay, can I start back up? Any objections to continuing? Okay, cool. Cool. So let me draw a picture of what a positive association might look like. We'll come up with some new variables. Scribble down. So let's have one of our variables be height, measured in centimeters. And let's have the other variable be weight. Measured in kilograms. Okay, these are obviously numerical variables, they are numbers. But what sort of numerical variable are they? So you got the two types. No, because they're numerical. You're numerical or categorical. These are definitely numbers. Because they are things which are measured. So these are measured, so they are continuous. Okay. Now, let's make our little axis. So we'll have our x-axis be how tall someone is. This will be the height measured in centimeters, and the y-axis will be the weight measured in kilos. Okay, and our subjects will be people. People, yeah, just people. Okay, so that means we're going to go to each person and we're going to record their height and their weight. Now, what do you think happens as people become taller? What usually tends to happen with their weight? So if you look at taller people versus shorter people, what could you say relatively about their weights most of the time? It increases, right? Yeah. So if you look at someone who's very short, their weight will probably be very small. I mean, there are like super heavy people who are short, but in general, shorter people will weigh less than taller people. Now, that's not always the case. Like, if you look right here, here's a tall, light person, and here's someone who's shorter than them but weighs more. So does that make sense? It's not always going to happen that just because you're taller than someone that you're going to weigh more than the shorter person, right? But it tends to happen. So the key word here is that what tends to happen. Okay, let's just put in some more dots. In general, people who are taller usually weigh a bit more. Okay, so if you draw what's called the trend line, it seems to go like this, and you can see that it has a positive slope. So we talk about a positive association between height and weight. Okay, so my question here is, does this difference between the positive association and negative association, do you think you could tell the difference by looking at the graph so far as in the examples that I've given? Or do you have questions? I'll wait to see if there are questions about that. because I know people are writing. Thank you again for having your cameras on. I can sort of just tell when people are writing. It makes life a lot easier for me. So we've got our negative association, we've got our positive association. It's about what tends to happen. So if there seems to be an association or relationship, so we use those words interchangeably. If I'm talking about an association between variables, I mean that those variables seem to have some sort of relationship. So association is basically equal to relationship. In other words, like if one gets bigger, the other gets bigger. Or if one gets smaller, the other gets smaller, or maybe one gets bigger and the other gets smaller. So do they tend to change together? So you talk about an association or relationship of variables if the variables tend to change together. Okay. If there is an association or relationship between the variables, we say that the variables are dependent. We get that because they depend on each other. If this one gets bigger, the other one also usually gets bigger. So this is sort of annoying because there's like 3 different words that mean the same thing. If we talk about an association between variables, we mean that there's a relationship between the variables, which means that the variables are dependent. So you might encounter any of those 3 words, but they practically mean the same thing. So there are 2 types of relationships or associations, negative or positive association. In both cases, you would say that those variables are dependent. That's a good question, actually. But yeah, that's what I mean by they're practically speaking the same, even though they don't literally mean the same thing. Okay. So, what about if there is no association? So if the variables don't tend to change together, i.e. there is no discernible pattern, there is no relationship, we would say that there is no association or no relationship. In that case, we say that the variables are independent. Either there's some sort of relationship and there's a positive or negative association, or there seems to be no connection between the 2. We would say that those variables are independent. And I'll show you what that looks like in a second. Okay. So let me show you, I'm going to scroll down a little. What does it look like when there seems to be no connection between the variables or no relationship? So let me draw my x and y axis. Boom. Let's come up with some variables. Let's say, how about, let's look at, one of the variables will be shoe size. And I'm thinking that's a continuous variable because like shoe size, I guess you could say it's continuous or discrete, but it measures the length of your shoes or your feet, right? So that's like a measurement, but they're also only whole numbers. Well, no, there are half sizes, so I guess you could say that it's continuous. Either way, it's definitely numerical because it measures something. And let's have the other variable be GPA. Okay, do you think that people with bigger shoes will have higher GPAs? Or people with smaller shoes, will they have higher GPAs? Do we really expect for there to be any connection between them? No, yeah, I wouldn't think so. Yeah, so you're probably going to see something that looks like this. You're going to have people with small feet with high and low GPAs, and you're going to see people with big feet with high and low GPAs. So looking at this, do you see how you just get sort of like a random cloud of dots? Like it's not very obvious that they're going up or they're going down together or something like that. So if you get something that looks like a random cloud of dots, that probably means that the variables are independent. There's no connection. So I would say that there's no discernible pattern. Ergo, they are independent. Cool. And eventually we'll get more into this and we'll look at like real data, not just junk that I've made up. And I'll show you how to make the graphs and all of this, but we're like, it's baby steps. Does that sort of make sense? Like right now we're just introducing the vocabulary that you will use later. Part of this will be to show you like how would you have the computer take the information and make all of this. So we'll get into that eventually. Boom. Yay. So we've talked about the relationship between variables. This is good. So we're going to continue on with this. So, actually I want to show you something that's really cool. So give me a second, I'm opening this website. Okay, I'm trying to find it. Oops, sorry. Where did it go? Okay, I found it. Okay, let me change my screen. Change my window capture to... There we go. Okay, does everyone see like a bunch of dots? Like big circles? Okay, cool. So this is a website where you can actually look at different variables across different countries. So over here on the right, you see where it says world regions. So do you see how in green there's the Americas, and then in blue or teal there's like Africa? Okay, or is that being, I think that's being covered by my face. Let me move my face. There we go. Okay, top right hand corner. Does everyone see The green is like the Americas. You have like blue for Africa. There's like this magenta-ish stuff is like Asia, and yellow is like Russia and Europe. Can we see that? Okay, cool. So what we have here is income on the x-axis and life expectancy on the y-axis. So you can see that as countries become richer, the people seem to live longer, right? Like if you like go and look at a country, like here's China right here. Okay, does everyone see how I have China highlighted? Apparently, what's the amount of money people make on average in China? It's on the x-axis. Can we see it? Or is it stuck from my head? I can't tell. Can we see it? What's the amount of money that people seem... Yeah? Yeah, 18,000. And how long do they live? Yeah, cool. So now let's go down a little. Let's go to India. They make less. They make about 7 grand a year, and they live less, about 69 years. And let's go to Nigeria. They make about 5 grand a year, and they live 65 years. And you go over to here, they make 1,200 a year, and they live 60 years. If you go over to here, this green, this is America, we make about $57,000 a year on average, and we live about 78 years. There seems to be a general trend that the richer the country is, the longer people seem to live, right? Okay. So we have a question here, or a question arises. I'm going to switch back over to writing. Let me change my window capture. Okay, so let me type in. Okay. So we have 2 variables. One of the variables is income, average income, and then the other variable is life expectancy. And you start wondering, there's obviously a relationship between them. But the question arises, do rich countries live longer because they're rich? Or are rich countries rich because they live longer? In other words, which one causes the other? Okay, this is a legitimate question, right? We're noticing a pattern, and you want to use that pattern to help somehow. So you know, if you want to increase people's lives, like, is it possible, like, if they make more money, will they live longer? Or is it the other way around? So which one causes which? So which one causes the other? That's the real question here. There seems to be a connection, but we can't say for certain how that seems to work. Okay, and I think this is a good time to take a 5-minute break because we've been going for a while. Okay, so you can finish writing, but I'm going to step away from the computer for 5 minutes. So I'll leave this up. Don't worry about it. Okay, so let's return at 1:50. we back? Are people back? Excellent. Some people are. Okay, cool. Let's keep going. Oh, yes, the reacts. Okay, so the question becomes, like, which one causes the other? Ideally, you'd like to figure it out so that you can either make people live longer so that they become more rich, or you can give people more money so that they'll live longer. You want to figure out which one causes the other. So we're going to talk about that eventually. But for now, there's some vocabulary you need to know. So the one that you think causes the other is called the explanatory variable. So let's write that down. Okay, it's not letting me. The variable which causes a change in the other variable is called the explanatory variable. So called because it explains the changes you see. So the explanatory variable is the one which seems to do the changing. Now, the variable which is changed is called the response variable. So the explanatory variable is the one which seems to cause some sort of changes. The other one's called the response variable because that's the one that you're hoping to change. It's the one that you're looking at. So normally what we write is we write explanatory response because the explanatory variable changes the response variable.
De comer. Es hora de comer.
What?
It's time to eat.
I don't think that's how you say that, but whatever.
No, it is, Dad.
I'm pretty sure my students who speak Spanish would beg to say otherwise.
You know nothing.
Yeah, es hora de comer. I don't know if that sounds right. I don't know. I only grew up speaking Korean. And English, obviously. I'm gonna move myself back up to the top right corner. Okay, cool. Okay, so let's keep going forward. Oh, okay. So now we're going to talk about, so what needs to happen so that you can say one variable causes a change in another variable. So cause is a very strong statement. If you say that one thing causes another, we literally mean that it causes. That is different than association. Two variables are associated if we notice a pattern between them. That does not necessarily mean one causes the other. So in statistics, saying that something causes the other is a very, very strong statement. It is much better to say that the variables are associated. Because when you say that something's associated, you're just saying, like, look, I'm noticing a pattern. I don't know which one, if any, causes the other. There's just this pattern that I am noticing. So how do you know whether your information is strong enough to tell you if one variable causes the other, or how do you know if you can only talk about association? That's what we're going to talk about now. So like, when is it appropriate to say one thing causes the other? When is it appropriate to only say that they're associated? And then I know people are writing, so I'm just like pausing. Oh, yeah, and I'll type it. What the hell? Like, might as well. So you're talking about like, when do we know it is appropriate to say the variables cause each other, or if they're only associated? That question? Is that what you were referring to? Okay, cool. Yeah, well, yeah, I mean, that's basically what the class is about. Does that sort of make sense? Like, that's one of the things that we're interested in figuring out. Like, when should you say they're associated? When should you say one causes the other? Mm-hmm. I'm putting myself on spotlight so that in case anyone makes noise, it will just stay on me. I'm assuming it's probably been showing me the whole time, but I don't really know. Oh, okay, so it wasn't sometimes. Okay, now it is. Oh, and while you're writing that down, I'm always like making tea, so I'm just gonna quickly go check on that. Oh wow, this is pretty good because I'm actually seeing what you see now. Like, it's actually very readable. I'm like sort of amazed. This is cool. I'm like so proud of my setup. Okay, I'm gonna scroll down. So because this is such a important thing to know about in statistics, we have a bunch of vocabulary that basically tells us like, oh, can you only talk about association? Or, oh, is it okay for you to talk about causation? Does that make sense? Like, this is like such a fundamental thing that there's like particular words you say and everyone knows, like, oh, you said that word, like, we can talk about causation now. And you've heard these words before is the funny thing. Like, they get used a lot. So whether you can say one or the other depends upon the type of study that you have worked with. So if someone talks about a study, and in particular we call it an observational study. Let me write that again. So if someone talks about a observational study or a study, observational study, that means that the way they collected the information means that you can only talk about association. And we'll talk about what happens so that works that way. So if a study is done, at the end of the study, you can only say, hey, this variable is associated with that variable. So you have people heard in the news where they talk about like scientists do a study and they have found out that this causes this? That's wrong. If the results are from a study, you can only say that the variables tend to happen together. In other words, they're associated. The other possibility is whether the scientists did an experiment. If an experiment was performed, then you can say that one variable conclusively causes the other variable. So if the results of the experiment are blah, then you can say, oh, because we did an experiment, we know that this causes this. But if it's a study, you're like, I don't know, this just seems to go along with this. So very important distinction. Sadly, this distinction is usually not talked about correctly in the media. Like you'll see like people talk about scientists do a study that means that, smoking causes cancer. Well, because it's a study, you can't say that whatever causes whatever. Like inherently, that means you can only talk about association. Okay, so what we're going to talk about now is like, well, what is the difference between an observational study and a experiment? Okay, and it has to do with how you are placed into those two groups. So we talked about this maybe like 2 classes ago. Remember when we were looking at like the vaccine, whether it was effective? What were the 2 groups that you could be placed into? There were 2 types of groups. Treatment and control groups, yes. So you might remember that the treatment group, let's write this in white. The treatment group gets the treatment. And then the control group, they got like a placebo. So if your treatment is, a vaccine, the treatment group gets the vaccine. If the control group would get like a placebo. And whether you have an observational study or an experiment comes down to how the people were placed into these groups. Okay, in an observational study, the subjects choose which group they are in. But with an experiment, the researchers randomly assign subjects to the groups. Okay, so it comes down to how people were placed into the different groups. If somehow the subjects had any control over it, and this will be sort of interesting, we'll talk about how that works out, you can only talk about association. But if the people are randomly placed into the groups by the researchers, or just in general, randomly placed no matter how it happens, then you can talk about an experiment, you can talk about causation. So let me give you like some examples of this. So let's say that you're looking at, you want to assess the effectiveness of tutoring. So what you decide to do is that all students who have a GPA over 2.0 are placed into the treatment group. Okay, what's the treatment group going to be? That means that they get, what's it called? They get tutoring. All the students who have under a GPA under 2.0 are placed into the control group. They don't get anything. Okay, now, do you see how it's the researcher who's choosing which group you go into? Or it looks that way? That's actually not the case. How are the students, in some sense, actually determining which group they end up in? This is a little tricky. But like the students are actually choosing which group they end up in. Yes, exactly. So it's because of the decisions the students made in the past, and you're measuring their grades, and that has to do with the choices that they made. So implicitly, the students had chosen this. So implicitly, students chose or determined their GPAs. So in other words, at the end of this, because you only have a study, you can only say that tutoring and getting a higher grade are associated or not. Okay, you can't say that tutoring causes higher grades or lower grades. To make that work, you would have to randomly place students into the tutoring group or the non-tutoring group. So is that sort of making sense? Like, these are tricky sometimes because you can implicitly, very often, the way you set things up, and this is why researchers have to be very careful, it's hard to actually make an experiment. Because a lot of the time, if you want to work with a particular group of people, implicitly, there's something about them that you're choosing, that they chose in the past, so that they're actually placing themselves. Even though you feel like you're choosing them. Like, you feel like you're choosing students who have a GPA under 2.0, but really, it's the subjects who determine that, and that makes it a study. So that's sort of tricky sometimes, and I just want to know if there are questions about it. Okay. I know people are still writing probably too. And we're almost done, basically, aren't we? Yeah, we have like a couple minutes left. Let me look and see where we are. This is a good place for us to end because the next topic is going to be like a lot of stuff. I'm not going to be able to cover that in like a couple minutes. So we're just going to end a little early. I'm going to stop the recording. I'll stay behind and answer questions, but I'm just going to stop it.